Alright, hello everyone. I want to build a personal finance assistance application which will run both on mobile and desktop. And today I'd like to design the system, to do the system design. And for that I will open the ChatGPT, which will assist me with designing the system. So let's start. Okay, so I will provide the description of what I want to ChatGPT. Okay, personal assistant app works both on desktop and mobile. Multiple accounts. Records in, out, amount, account ID, description, expense ID, contractor ID. What else do we need? Let's also date, maybe time. Next we will need information about account. Account is basically current amount, and then we will need currency, name, description, and here we will need also attachments, description. What else do we need? We will also need statistics, say for monthly statistics. We will also need we will need recurrency. A record is recurrent with the recurrency ID. Can be detached, updated, etc. Recurrency can also be updated, but the changes will be applied only to the planned, not actual records. So, and here we will also need the record can be actual or planned. So recurrency ID. Okay. Statistic monthly pre-calculated. Okay. What we also need is the infrastructure. Infrastructure will be AWS, no domain, no database. Oh, we also need it to be encrypted, client side encrypted, so that data is stored on the backend encrypted. Okay, no database, data storage as 3. Client will okay, clients, desktop, iOS. We'll start with iOS. Data sync with the S3 storage. Data broken into monthly account chunks to minimize data sync. Okay, so when data changes on one of the clients, it will also change on the backend to allow other clients. Synchronization. Okay, let's see what it suggests now. Suggest system design. Okay, let's start with system design. Okay, given your requirements, I'd lean towards an offline first encrypted personal finance application where S3 acts as an encrypted object store instead of a database. This keeps infrastructure extremely simple while allowing synchronization across devices. High-level architecture, desktop client, local encrypted cache, synchronization engine, HTTPS goes to AWS. Okay, API gateway, Lambda functions, upload, download, merge. Okay, S3 bucket, iOS client, storage layout, bucket users, user ID, manifest JSON, accounts, chunks, statistics, attachments. Good. The manifest is the entry point. Example, version, accounts, updated chunks, statistics. Good. Clients first download only the manifest. Chunking instead of downloading all data. Account month chunk. Example, checking cache. Chunk contains only records for one account, 1 month. Example, JSON, record 2, record 3. Most users modify only the current month, making it efficient. Okay, record module. Okay, we will do that later. Okay, let's keep it for now. Recurrency, add separate recurrence definition from generate records. Okay. Recurrency, recurrence definitions from generated records. Separate generated plant records contain recurrency ID generated. When the user edits one occurrence, detach recurrency ID null. Okay. Changing the recurrence, regenerate future plant records. Accounts, statistics, encryption, everything on one client. Okay. Key, derivation, password. Okay, that's the encryption stuff. Authentication. It suggests using AWS Cognito. Attachments. Attachments can become large. Yes, they can become large. Metadata remains in the records. Sync algorithm. Okay. Download, conflict resolution. Avoid last write wins alone. Revision update. Okay. AWS stuff, authentication, Cognito, Gateway, Lambda, Amazon S3, notifications, optional, Amazon SNS or WebSocket API, secrets, AWS Conf Instance Manager, parameter store, monitoring, CloudWatch. Suggested improvements. A few additions would make the system more robust and scalable. Event log. Instead of only storing the latest chunk, maintain an encrypted append-only change log for efficient incremental sync and easier conflict detection. Event log. Okay, per object manifest entries. Store a content hash, encrypted size version for every chunk to avoid unnecessary downloads. I agree. Stable IDs. Okay, use UUID v7. Okay, compression before encryption. Okay, data format. Consider a compact binary serialization such as protocol buffers or CBOR before compression to reduce storage and bandwidth compared with JSON. Overall, the architecture stays true to your goals. Okay, good. First of all, let's make it be very brief for all next messages. Good. Next, let's reduce AWS usage. No Cognito. Authentication by the UUID. Okay, encryption or the encryption key generated locally. For example, encryption local only. In case of key loss, data will be lost also. Good for now. Okay, what else do they suggest to use on AWS? Okay, no API. API, no lambda, only direct access to storage. Storage is configured on the client. Storage path and access is configured on the client. Every user can use their own infra. Okay. Free version, single user. Okay, notifications, no need for now. Secrets. What secrets do we need to store? I'm not sure if we need to store any secrets. Monitoring, no need to pay special attention. Everything just out of the box. Just out of the box. AWS defaults. Okay, API gateway, no need API gateway. Okay, so what we need, so the goal is minimum AWS cost, ideally only S3. Review the design. That's a good direction. I'd simplify it further. AWS S3 only. Authentication, no authentication. Good. User configures bucket, region, AWS access key, AWS secret key. Or use any S3 compatible storage, Mini.io by Blaze v2, Cloudflare R2, etc. Encryption client side only. Key generate locally or from passphrase. Never uploaded. Lost key, lost data. Acceptable for now. Storage, bucket, manifest JSON, accounts JSON, chunks, attachments, statistics. Good. Synchronization, download manifest, compare hashes version, download change chunks, upload modified chunks, update manifest last. Okay. Conflicts, record revision plus update add last write wins is probably sufficient for a single user. Yes, will be good for now. Local DB, SQLite, maybe. Secrets, only AWS credential if using AWS S3. Store them in OS, secure storage. MacOS key change, Windows credential manager, iOS keychain, maybe. Cost, for typical person using S3 standard is likely only a few cents per month. Most cost comes from attachments and request volume, which should remain very low. True. Overall, this becomes an offline first encrypted SQLite app with S3 as a sync target, keeping infrastructure and operating costs close to zero. Okay, let's build the design, the initial design spec as MD, as markdown. Keep placeholders for okay for most of the sections, e.g. synchronization and encryption. etc. Okay, that will be our first design spec. Design specifications, architecture, overview, to do. Okay, overview, to do. Components: desktop client, iOS client, local SQLite database, S3 compatible object storage, infrastructure requirements. Okay, one thing we need to clarify: iOS app install without App Store. Xcode, Apple Developer Program, test flight, install directly in your own device. App expires. For personal, if you want permanent installs without re-signing every 7 days, you need Apple Developer Program. Okay, $99 per year. Good. So then other options, e.g., for example, local web app. Runs a small local server. Full desktop capabilities. Doesn't work well without a companion app. PWA. Okay. iOS PWA packed as an app or something like that. Wraps your PWA in a native iOS app. Access to native API, keychain, most of web code still requires Apple. Okay, desktop, VS Code, dev container, web app. Okay, okay, so we still need to find out a solution for iOS, which doesn't require resigning every 7 days. We still need to find a solution for iOS without resigning every 7 days. Xcode plus free Apple ID. If you want a native iOS app, is effectively the only practical long-term solution. Okay, what about App Store? I think it's not. Yeah, it still requires payment. Okay, then what about PWA on iOS, encryption, local database, browser native only. Okay, encryption, client-side encryption also works. Browser provides S3, but don't store AWS. Okay. Use enter S3 compatible credential, encrypt and store locally. Use them only from the browser. However, configuration is required. Use pre-signed URLs. Nothing else. For your app, a realistic architecture. iOS PWA, indexed DB, encrypted local data, sync engine S3. Okay, S3 access from PWA. PWA can access S3 directly from the browser using AWS SDK, but you need course. That will be an issue. Credentials. The problem is credentials. User provides S3 credentials. Works a personal app. Now backend. Option B, temporary credentials. Typical production approach. Okay. Okay. What about public bucket? Public bucket encryption. Encryption is enough. The path permanent path storage on the PWA. Yes, public, but you need to define the threat model. Architecture encrypt, PWA encrypt, upload ciphertext. Yes, public S3 bucket, good. Anyone can download, good, but only someone with an encryption key can read it. No credential, no backend, works from PWA, works from any static object storage, zero auth complexity risks. Anyone can discover, download encrypted data, delete, replace files, unless write is protected, perform traffic cost abuse. Mitigations, separate bucket per user, random unguessable paths, enable S3 versioning, keep a local manifest backup, use object integrity checks, permanent path storage in PWS, yes, but don't rely on the browser alone. Options, store configuration locally, index DB, works until browser data is cleared, iOS evict storage, better use recovery phrase store, word recovery key. Okay, the app can reconstruct everything from bucket path recovery key recommended. Use a public read-only bucket S3. Okay, so this is what ChatGPT recommends. Use a public read-only bucket for S3 encrypted immutable objects, PWA local index DB cache. For writes, either allow public writes, which is not recommended, yeah, that's very dangerous, or use a tiny upload relay later. The main missing piece is write authorization. Encryption solves confidentiality, not integrity or availability. So the problem is that if we use the public bucket, which will unlock PWA use on iOS. Someone who knows the path can erase or rewrite all the data. Good. That will be okay for now. The risk is minimal, and we can find a way later. For now, it will be good enough. Okay. Public read write with encryption, with local encryption is good enough. Good enough as public S3 storage is public S3 storage is the golden source for all local apps, desktop, mobile, etc. Update the design spec. By personal assistant, design specification, goals of offline first, desktop plus iOS. Yes, offline first is good. The mobile app will sync when the connection is restored. What else? Goals: desktop plus iOS, client-side encrypted data, user-owned storage, no backend, minimal infrastructure cost, S3 compatible public storage as a source of truth, multiple independent clients. Good. Architecture overview. The application consists of web PWA client, desktop client, iOS client, local encrypted database, public S3 compatible storage. All clients synchronize directly with storage. Okay, one more requirement. Single code base for all clients. For example, web-based Vue.js, for example. Updated design goal. Okay, client strategy. Single code base. Application uses a web-based client architecture. Primary stack Vue.js, TypeScript, AWS, shared business logic. The same code base targets web browser, iOS, PWS, desktop application. Okay, client packaging. Web PWA, primary runtime. Provides offline support, IndexedDB storage, web crypto encryption, S3 synchronization, iOS distribution, PWA installed from Safari, optional future capacitor wrapper if native APIs are required. Okay, desktop. Initial browser, PWA, good, future Tauri. Okay. Drop capacitor and Tauri. Keep the boilerplate minimal. Okay, good. Okay, provide design spec as one MD file in Canvas so that we can download it. Show it. paste it directly here. Good. Copy, and now let's create our repository for this. Suggest a name for the application. Budget click. Good. Keep budget click 2. All right. Now let's create a repository. For that, we go to GitHub and create a new repository. Will be BudgetClick-2026. Okay. Public. Let's keep it public. Add readme. Okay. Create repository. Good. And now we need to clone it locally. Git clone cd budget click take open VS Code. Okay, and create the file. First file, design markdown, and now copy all this. Good. That will be our first design spec. Let's see how it looks. Personal assistant. Okay, remove this. And this. So this is our first design spec. Let's have a look. Personal assistant, personal finance tracker, design specifications, budget click 2. Okay, 2026. Personal finance tracker, design specifications. Good. Goals: offline first personal assistant application, personal finance application, single code base for all clients, desktop plus iOS plus web support, client-side encryption, user-owned storage, minimum infrastructure cost, S3 compatibility, storage as a shared source of truth, no backend services, architecture overview. The application is a web-based offline first client, client's web browser iOS PWA, desktop browser PWA. All clients share the same Vue.js plus TypeScript code base, Vue application, shared core logic, IndexedDB, S3 storage. Good. Technology stack: front-end, Vue.js, TypeScript, PWA, browser APIs only. True. Local storage: IndexedDB, which is the browser default. Local cache. We'll see. What about local cache? What about local cache? Is this indexed.db? DB or browser. file system. Good. IndexedDB, not browser cache. Recommended. IndexedDB, appropriate browser cache API. Okay, file system not available. Good. Updated architecture, system IndexedDB. The app should treat IndexedDB as active. Okay, good. Local cache, IndexedDB, local offline operations, remote storage, S3 compatible object storage. Examples: Cloudflare. Good. Infrastructure principles, no backend. Security model, all in locally before upload. Storage contains only encrypted objects. To do key derivation, encryption algorithm, file format. Okay, so all that is to do. We'll come back to this. No application authentication, that's good. Identity is based on storage location. Local configuration, encryption key, true. User setup flow, recovery flow. Okay, we'll come back to this. Storage layout bucket, manifest JSON. Okay. Storage layer, all objects are encrypted. Data model, record ID, in out amount, account ID, description, expense ID, contractor ID, date time attachments, actual recurrency ID, to do schema, versioning, deletion, model, account, field, recurrency, ID, name, description, currency, current amount. Schema, recurrency, records can belong to a recurrence, planned records are generated from recurrence. Data model, generation algorithm, local database, schema, indexes, migration. That one is important, migration strategy. A local database contains decrypted, true. SynQ, true. Indexes, true. Cache statistics, true. Synchronization, offline first model. Local changes happen immediately when connection. Synchronization happens when connection is available. Triggers, application setup, connection restored, manual synchronization. Okay, manual synchronization. Okay, let's keep it for now. To do synchronization protocol, manifest format, change tracking, conflict resolution, retry strategy. Sync flow, user action, local database, synq, encrypted S3 objects. To do upload flow, download flow, merge rules, statistics, monthly, pre-computed statistics. Okay, stored encrypted. Good. Calculation rules, to do. Okay, so we'll come back to all of this. Attachments are encrypted before upload. To do storage format, metadata deduplication, client structure, view application, storage. Okay, client structure. What is it? Apps, web. Okay, it's probably like this. Okay. Apps. It's probably it should look like this. Maybe. Not sure about that. Okay, let's keep it like this for now. Okay, view application, packages, core, data model, sync engine, encryption, statistics. View application. Okay, maybe storage index DB adapter S3 adapter UI shared components. Something's wrong here. Storage view application. Maybe it should be like this. Yeah, probably like this. Packages. Okay, something's wrong here. Okay, client structure. Let's ask, what do you mean by this? Can you make it more readable? A more readable version, conceptually. Update, provide dated down section. Still, okay, let's see what they suggest. Client structure. Client structure. Let's remove this and remove this. Good. Don't save. Client structure. Okay. So let's see what is. Okay, client structure. Here we go. Source, app, core, data models, sync, encryption, storage, components. Okay, let's keep it for now like this. We can revisit it later. Module responsibilities. Okay, app, core, sync, encryption, storage, iOS PWA, uses the same web application, capability, desktop, future improvements. Okay, so that will be our first design spec. Next, in the next step, we will design the application. We start designing the application, and we will also need to go through all those to-dos. Yeah. What else do we need to think about? Anything else here? Let's ask ChatGPT. Okay, here's the latest. Below is the latest version of the design spec. Do initial version is okay. Do we need to think about anything else before actually starting sketching out the app and the markdown? The design is already good enough to start sketching. Before coding, I would only add a few decisions that will prevent painful rewrites later. 1. Define the sync model first. Most important. Use your biggest is not view S3 index DB. It's how changes are represented. Decide, do you sync whole monthly chunks or sync operations events. Okay. Okay. Monthly chunks for each account. Operations not possible without API. Good. I would add changelog. Each client maintains an append-only change log. Example ID. Each client maintains an append-only change log. Change log. Do we need a change log? Okay. Change log, local only. Okay, good. Let's add it. Won't hurt. It won't hurt. You can still periodically compact changes into monthly chunks. Define IDEs and timestamps. Decide now. Use for IDs. UTC timestamps everywhere. Okay. IDs. We will use simplified AZ09, let's say 8 length unique IDs, less space but still powerful to encode millions of records for a single user. This should be more than enough. We will use our own generator for a space enough to encode. For single user, we'll use our own generator. Integrity check. Data chunks are 1 month limited. So IDs are very hard to become duplicated. What do you think? For the future proof design of this. What do you think about of this? Okay, what else? Delete behavior. Do not physically delete sync data. Use tombstones. Delete it through. Okay. Delete strategy. Good. Accept it with the tombstones. Okay, encryption format. Also important, encryption format. Before implementing, decide the envelope version, algorithm, nonce ciphertext, check some, otherwise changing. Good. Format envelope is good. User onboarding. User onboarding storage setup. User onboarding. Keep all in setup config UI. No onboarding. We may address this later if we make this multi-user or used by or public use or used publicly. Okay, so that means that we don't need the user onboarding for now. Okay, S3 write security. Current design says public read-write bucket. Yes, that's the main risk, the biggest risk. I would at least document the assumption. Yes, S3 write security. Of course, this has to be documented. Later we may address this, but for now, let's keep it stupid and simple. Although this violates our principle, security first. Okay, for now we will change it into simplicity and cost efficiency first. What else? Define first MVP. Wow, okay, MVP scope. MVP scope, okay, let's do it now. Okay, MVP scope. MVP scope will be PWA iOS plus desktop apps. Freeze account record, category expense, contractor, attachments, monthly status. Good. Exclude initially, recurrence. Oh, really? Okay. Multi-device conflict UI. Okay. Advanced reports. Sharing. Recurrency is deceptively complex. That's true. That's true. Okay. All agree to all. Recurrency. Keep design requirements for this, but leave it for the next iteration. Good. MVP, just track the the actual spends, accounts, spend categories, contractors, attachments. Good. Actual spends and planned spends too. The only difference is actual flag in the data, in the record data, the record schema, data schema. Good. Okay, next, add application state model, printer or app state composables, direct index DB access. Okay, next, 8 state, app state. Keep super simple. Home built app state layer will be enough. DB access through home built sync layer. Good. Home built sync layer, DB state sync layer. Good. What else? Testing strategy. 9. Testing strategy. Testing strategy. Wow. Okay. Encryption test, sync test, migration tests, offline scenarios, especially device offline. Okay. Testing strategy. Do you mean automated tests or user test scenarios, manual test scenarios? Good. Non-goal sections. What is it? Prevent scope creep. Breaking integrations, cloud accounts managed by us. What is this? I don't understand. Server-side analytics. Yeah, by the way, well, let's add the iteration, user onboarding, MVP scope, agreed to all, recurrency. Okay. Monthly stats reports can also be another iteration 3, for example. Okay, non-goal section. I don't understand. My priority order before writing code. Sync model, encryption format, data schema, local DB schema, MVP screens. Important. Don't understand. Clarify. More migration. Important. DB migration strategy. DB schema migration. DB schema data migration strategy, because we will be changing the data schema during development, and we need a good strategy for migrations, for database migrations. Okay, what does it suggest? Priority order before writing code, sync model, encryption format, data schema, local DB schema, MVP screens. Okay, let's address all this in the next video, and for now let's just finish this. Okay, let's see first what ChatGPT suggests. Okay, overall the direction is consistent. I would adjust only a few things. Sync model, agree, S3 objects, monthly chunks per account, no operation sync to S3, local operation log only updates. Good compromise. Synchronization model. Okay, let's update this. Well, first of all, let's push this as the first commit. Okay, initial design spec. Good. Publish branch. That will be our first commit, initial commit. Okay, it should be here. Let's reload. Good. Okay, there's no readme, but there is design markdown, which will be good for now. Right. What do we do next? There was a section of synchronization. Okay. Synchronization model, security model, storage, data model, local synchronization. Okay, it's here. Synchronization model. Let's check what we changed. What's changed? Offline first, remote synchronization, account plus months, local changes happen immediately, sync happens when connection is available. Each chunk contains the complete state for that period. A local change log is used only to track local modifications. Okay, keep it here. IDs. This needs a bit more thought. Okay, a 4-character gives 14 million combinations for a single user, probably okay. However, records, attachment, accounts, contractors, categories, Samsung all share the same names unless separated. You can improve without much complexity. Option A, keep 4 chars but namespace IDs. Okay, like this. Maybe, yeah, looks good. Now collisions are independent. That's true. Option B, use 5 characters. Adding 1 character will increase to almost 1 billion possible combinations. Still tiny, really? My preference. 4 characters for human-facing IDs plus internal random uniqueness check. Good. This is what I suggested. Your monthly chunking makes collisions very unlikely. That's true. So it basically suggests what I suggested. 4 characters for human-facing ID. Still tiny. It means that the ID will be still tiny, 5 characters, but giving a huge number of combinations, almost 1 billion. That's impossible to overflow for one user. Your monthly chunking makes collisions very unlikely. Okay. Record, account, file. Good. Stick to this. Option B. Okay, delete strategy. Accepted. Good. Do not remove until a future go. Okay. Encryption envelope. Accepted. Onboarding. Agree. Configuration. No accounts, profiles, login. Security priority. Agree with the pragmatic approach. Security priority. I would update the before. Security first, client-side privacy first, minimal infrastructure first. Document. Confidentiality, protected integrity, partially protected. Availability depends on storage. Okay, MVP Scalability, agree. App state, yes, good for now. Yeah, good. Testing strategy, I mean both. Excuse me, that was wrong. No, okay. What's next? App state, testing strategy, I mean both. Automated tests. Okay. Non-goals clarification, it means explicitly, okay, for the tests IDs stick to this. Testing let's add tests, automated tests of each iteration, automated tests plus user scenarios in the end of each iteration. Good. Testing strategy, scenario, non-goals clarification. It means explicit. What is non-goals clarification? It means explicitly writing what the app will not do. Okay. Non-goals. The application will not provide user account, cloud storage, banking integration, server-side analytics, social features, shared wallets. It protects MVP from expanding migration strategy. Okay, good. Non-goals. Non-goals accepted. Update the spec. Good. Migration strategy. Important. What does it suggest? Data migration. All stored data has a schema version. Migration flow. Load object. Check schema version. Run migrations sequentially. Save new version. Never modify old migrations, add new migrations. Only migrations must be deterministic. Test migration from every previous version. Final architecture decisions before coding. Okay, IndexedDB. I will need to find out what this IndexedDB is. Is it JSON, or is it relational database or non-relational database? So I will need to find out how to organize the migration, the data migration during the development. Database schema format, good. Yeah, so the next would be to design database design. Okay, we'll cover that in the next session. For now, this will be enough. Migrations, cover that next in future. Keep the initial recommendations. Stop. We'll cover this in another session together with the data schema, planning and data schema, planning, data schema, storage, maybe sync and encryption, planning, and yeah, good. Update the markdown. Spec markdown. Good. All right, copy this and paste here. Let's see how it looks. Right, okay, we'll remove this. Budget click, updated specs, strategy, technology stack, offline first, automated tests, yeah. Copy only this. Okay, let's see what we have here. BudgetClick 2026 personal finance tracker, design specification, goals, offline first personal finance application, single code base for all clients, desktop plus iOS plus web support. Okay, client-side encryption, user-owned storage, minimum infrastructure cost, S3 compatible storage as the shared source of truth, no backend services. True. Architecture overview. The application is a web-based offline first client, clients, web browser, iOS PWA, desktop browser PWA. All clients share the same Vue.js plus TypeScript codebase, Vue application, shared core logic, IndexedDB local data, S3 storage. Good. Technology stack, front end, Vue.js, blah blah blah, local storage, IndexedDB local cache offline operation, remote storage, S3 compatible object storage, examples AWS S3, infrastructure principles, no backend API, they can store database service, lambda notification service, only storage is required. Security model, encryption, all sensitive data is encrypted locally before upload. Storage contains only encrypted objects. To do key derivation, encryption algorithm, file format. Okay, we'll cover that in the next session. Assumption, loss of encryption key means permanent data loss. Okay, acceptable for now. Identity, no application authentication. Identity is based on storage location. Accepted. User setup flow, that will be to do. Recovery flow, that will be to do. Storage layout, bucket. Good. Manifest JSON, accounts, chunks, account ID, okay, we'll cover that in the next session. I don't like this one because it should be, because we use the bucket per one user, but this one is okay. Account ID is good. Oh, this account is meant. Yes, that's good. Yeah, keep it like this. Statistics, good. Attachments, good. All objects are encrypted. Are attachments encrypted too? Okay. attachments stored as flat list or separated by month to storage. To do data model record, okay, contractor ID, date, time. Oh, by the way, we don't have contractors in our data. We don't have contractors in the storage. Storage layout, security model, storage. Where are contractors stored? I think that we don't have contractors in this storage layout. Accounts, chunks, statistics, attachments. Yeah, no contractors. We do have accounts JSON. So maybe we will need to rename this. Rename accounts to reference, for example, and store all necessary reference data. Accounts, contractors here. Good. What else do we need to cover in the next session? Migration strategy, synchronization model, account plus month, synchronization, local change log, okay, sync flow, to do conflict merge rules, okay, we'll cover that in the next session. Statistics, monthly pre-computed statistics, good. MVP, to do, statistic is deferred. Calculation rules, storage format, refresh strategy, attachments are encrypted before upload. To do, storage format, metadata deduplication, client structure. The project uses a simple modular structure. The initial can be single client structure. Okay, let's keep it like this for now. We will cover that in one of the next sessions. Testing strategy. Testing is performed at the end of each development. Not performed. It is defined. Testing is defined. Testing is performed on each build. Automated test, user-generated tests, okay, we'll keep it like this for now. Non-goals, iOS PWA use the same limitations. Background execution, okay, we'll see how it goes. Desktop, future improvements. Okay, so one last thing before we wrap up this session will be, okay, let's first of all let's update design spec. One last thing I want to do before, let's create iterations MVP iterations, MVP, or what would be the name, or what is the best name for the iteration planning? Okay. Plan iterations. For example, the next will be refine design specs. Maybe 2-3 more sessions. Then set up the dev deploy environment, infra, build MVP, iteration 1, 2, and so on. Let's see what it suggests. Okay, suggested development roadmap. Okay. Okay, roadmap. Let's name it roadmap. New file, roadmap markdown, and copy and paste this. See what it suggests, how it looks like. Okay, how it looks like. BudgetClick-2026 development roadmap. Phase 0, design finalization, create enough technical before implementation activity. Refine, define data model, define IndexedDB schema, define S3 storage form, define sync strategy, define encryption format, define application state model, expected outcome. Stable technical foundation ready for implementation. Phase 1, development environment. Create a development environment, deployment foundation, set up repository. Okay, set up repository, that's done. Set up AI assisted tooling. New TypeScript project, container, local testing environment, deployment pipeline, S3, development storage, expected outcome application can be developed, built, and deployed. Okay, deployment storage, that will probably be S3 bucket for PA download install. Maybe. Expected outcome application can be developed, built, and deployed. And installed. Phase 2 MVP. Okay. Oh, wait a second. Development environment. Good. Phase 2 application. Okay, so that's application stub can be developed, built, deployed, and installed. Phase 2 MVP implementation. Build the first usable version. Okay, application shell, configuration screen, local IndexedDB storage, encryption layer, S3 connection, account management, expense categories, contractors, records, income expense, planned actual attachments, basic offline workflow, excluded, recurrency, advanced statistics, multi-device conflict resolution, multi-user features, expected outcome, personal finance, usable one user. Good. Phase 3, iteration 1, improve usability and reliability, activities, improve UI UX, improve data entry flow, add validations, I don't know what it is, improve, what is it? Okay, let's ask now. Validations, what is it? Improve sync reliability, automated tests, run user scenario tests, expected outcomes table, daily use version. Good. Phase 4, iteration 2, improve productivity, features, activities, recurrency, design, implementation, plan, transaction improvements. Okay, so when do we have our recurrency, refactoring, automated, recurrency, excluded, recurrency, iteration 2. Okay, good, looks good. Better search filtering, yeah, reporting capabilities, more automated personal finance management, iteration 3, advanced features, monthly statistics, reports, data visualization, export, import, backup tools, expected outcome, complete personal finance. Okay, so we will need 4 iterations or 5 phases. The current phase is phase 1, or the design, the system design. The first phase will be MVP, and the next 3 phases will be 3 iterations. So in total 5 phases. Every iteration includes development, feature, implementation, refactoring, documentation, updates, quality, automated tests, user scenario tests, manual validation, development, feature implementation, refactoring, documentation, updates. Good. Quality, automated tests, user scenario tests, documentation. Okay. And the last thing, after the last thing, let's commit this. Add roadmap. I actually want in the future features, complete asset storage, including all kinds of assets, movable, immobile, shares, stocks, etc. with real-time net worth calculation. Future bank integrations, third-party integrations. I think we will need a very advanced backend for all this. Advanced backend and advanced maybe certifications or security or infrastructure. But I just want to add this, to add all the features that a professional, full-featured personal finance tracker application would need. What else? Multi-user, fully secure storage with secret storage, app official app. Keep the, oh, by the way, no goal, maybe it conflicts with no goals. Let's check. No goals, future improvements, optional private storage mode, barrier conflict resolution, version history, backup, snapshots, multi-user support, and known goals, user account managed by BudgetClick, cloud storage managed by BudgetClick, banking integration, server-side analytics, multi-user collaboration, shared wallets, social features. So maybe these non-goals will remain non-goals. Okay, let's keep them non-goals. Maybe in the future versions, if we want, if we need, we will make those our goals. But for now, what I want is some of them will conflict with no goals, but we would like to keep the design future proof, at least data schema. Considerations. What do you think about this? Okay, they keep it simple, but avoid painting the data model into a corner. I would not implement future feature now, but I would make a few decisions that allow them later. Remain the domain from finance to personal wealth system. Good. Good. I would keep the app name but adjust the internal model. Separate money movement from financial state today. This conceptual separation now. Example, category, add asset concept. Okay, let's add this future domain expansion. Okay, my menu before schema design. Do not model expenses as the core financial event. As a core entity. Model financial event affects accounts, affects liabilities. Okay. Do we need to? Okay, keep simple for now. Just make sure that we don't limit ourselves now, especially with data storage and model. Provide minimal updates to the schema. Oh, to the specification, design spec. Good. And that will be the final step for now. Replace storage layout section with the data model section. Add before. Okay. Provide complete design spec as MD. Let's see what's happening. And update design. Remove this and remove this and see how it looks now. How it looks like now. BudgetClick-20 personal finance tracker. Architecture overview, clients, technology stack, local storage infrastructure, security model, storage layout. Okay, reference, account JSON, contractor JSON, categories JSON, good. Statistics, attachments, all options encrypted to data model. Feature separate, okay. Record. Let's see how it changed. Let's compare. Let's see what changed. Front end examples. Encryption. Storage layout. Good. Yes. All objects are encrypted. Attachments are stored separately. To do storage optimization. I still need this. Data model. MVP focuses on personal finance tracking. The initial model should avoid limiting future expansion to asset tracking. Yes, initials remain simple. Record. Good. Exactly. This is exactly what I wanted. We keep it like this, and this will be good for now. The design spec will remain like this, and in the next sessions we'll go deeper into the data model, synchronization, security, data storage, and maybe something else. Let's update and commit. Design and synchronize all this. And this is what we have in our repository. We have two files, design, markdown, roadmap, markdown. We have planned implementation, and we have sketched out most of the design, and in the next session we will go deeper into the design sections, specifically storage, data, synchronization, and encryption.